Hello there, and welcome to the Bedtime Lab, where the wonders of the universe gently unfold like a tapestry of stars in the night sky. Tonight, let's embark on a serene journey through the cosmos as we unravel 100 sleepy facts about galaxies in space. This is a space where curiosity can float gently on the surface of your thoughts, inviting you to relax and explore the universe's mysteries before drifting into a peaceful slumber. As we settle in, let's create a cozy corner of the universe right here. I'd love to know, where are you listening from tonight? Please drop a comment and share. It's always a delight to see how people from every corner of the world gather here to unwind and share this cosmic journey together. Let's imagine ourselves floating through the vastness of space, surrounded by the gentle glow of distant galaxies. The universe, with its grand scale and intricate beauty, is like a vast ocean of time and light, and in this universe, there are over 2 trillion galaxies that we can observe. This number is far higher than what we once thought. Can you picture such an expanse? Each galaxy a unique island of stars, gas, and dust, each telling its own story across the eons. Speaking of stories and journeys, our own Milky Way isn't a solitary traveler through space. The Andromeda Galaxy, our nearest galactic neighbor, is on a slow-motion collision course with us. But there's no need to worry. This cosmic dance won't culminate for another 4.5 billion years. When you consider this timeline, it makes our human moments seem both fleeting and precious. Here's a fascinating fact. The oldest galaxy discovered so far is Jian Z1. This ancient collection of stars was born roughly 13.4 billion years ago, almost as old as the universe itself. Such an age gives us a glimpse into the universe's infancy, a time when galaxies were just beginning to form and light up the cosmos. In this vast universe, galaxies come in different shapes and sizes. Spiral galaxies, like our Milky Way, comprise about 77% of all observed galaxies. They are characterized by their beautiful swirling arms, where new stars are born. These spirals are like cosmic pinwheels, spinning gracefully across the universe. In contrast, elliptical galaxies, which can be more than 100 times as massive as their spiral counterparts, often appear as enormous, featureless blobs of stars. These are often the result of galaxies merging together over time, and then, bridging the gap between spiral and elliptical galaxies, we have lenticular galaxies. Think of them as the missing link, capturing features of both spirals and ellipticals. They gently remind us of the universe's complexity and the continuous evolution of galaxies in their cosmic ballet. Now, imagine the breathtaking sight of some of the largest known galaxies. Giant galaxies can contain up to 100 trillion stars. Each star is a potential sun, perhaps with its own family of planets. It's quite a number to consider, isn't it? These stars rotate around the galactic center, each at its own pace, creating a wondrous symphony of motion governed by gravity. Let's pause here for a moment to appreciate the sheer scale of these galactic homes. They embody the dance of creation and destruction, where stars are born from clouds of gas and dust and eventually end their lives in cataclysmic events, scattering elements that form new generations of stars. Speaking of which, some galaxies are teeming with what we call brown dwarfs, often described as failed stars. These celestial objects are not massive enough to sustain nuclear fusion like our Sun, yet they outnumber stars within the galaxies more than we once thought. It's a gentle reminder of how much there is left to learn about the universe. And here's something curious to ponder: the idea of dark matter. It's a mysterious substance that doesn't emit light or energy, and makes up about 85% of the universe's mass. Its presence is inferred through the gravitational effects it has on visible matter. The bullet cluster is one of the best pieces of evidence for dark matter, showcasing how galaxies within the cluster move and interact with each other. This interstellar journey through galaxies and their mysteries is like tracing a thread through the vast web of the cosmos. Each fact is a bead of knowledge, strung together by the string of curiosity and wonder. As we continue, let's allow these facts to slowly weave their way into our dreams, creating a tapestry of cosmic understanding that stretches across light years and through the fabric of time itself. Speaking of the mysteries of galaxies, let me share something unexpected about how we first began to understand these colossal structures. Before Edwin Hubble famously demonstrated that galaxies exist beyond the Milky Way in the early 20th century, many astronomers believed that our galaxy was the entirety of the universe. The concept of island universes, as galaxies were once known, was a bold idea for its time, challenging the prevailing views and expanding our cosmic perspective. Interestingly, the term galaxy itself comes from the Greek word Galaxies, meaning milky, a reference to our own Milky Way. This name evokes the ancient stories and observations of the night sky, where civilizations constructed myths and tales about the milky band of light spanning the heavens. The connection between mythology and astronomy reminds us of humanity's long-standing fascination with the stars. One curious detail about galaxies is that the vast majority of them are part of groups or clusters, bound together by gravity. It's estimated that about 90% of galaxies reside in these clusters. These cosmic gatherings can range from a few dozen to thousands of galaxies, all interacting in a complex gravitational dance. This means that galaxies, despite their vast distances apart, are not isolated entities, but part of a larger cosmic community. Consider this. Within these clusters, collisions between galaxies are more common than you might think. In fact, the merging of galaxies is a vital process in the universe, driving both the formation of new stars and the transformation of galactic shapes. However, even during such colossal events, the vast distances between stars mean that direct collisions between stars are exceedingly rare. Instead, gravitational interactions lead to tidal forces that can dramatically reshape galaxies, often creating new stellar formations in their wake. Another fascinating aspect of galaxies is the role of gravitational lensing. This phenomenon occurs when the gravitational field of a massive object, such as a galaxy or cluster of galaxies, bends and amplifies the light from a more distant object. It turns out that gravitational lensing not only helps us observe galaxies that are otherwise too faint or distant to see, but it also provides crucial evidence for the existence of dark matter. By studying how light is bent, astronomers can map the distribution of both visible and unseen mass in the universe. Did you know that some galaxies are traveling at incredible speeds relative to us? The galaxy known as the Great Attractor is pulling the Milky Way and thousands of other galaxies towards it at a speed of about 300,000 kilometers per hour. This motion is part of a larger cosmic flow, drawing galaxies across hundreds of millions of light years, further illustrating the dynamic nature of the universe. Here's something unexpected. The concept of dark energy, which makes up a significant portion of the universe, was first suggested to explain the accelerating expansion of the universe. Discovered in the late 20th century, dark energy challenges our understanding of gravity and cosmology, as it seems to work against the gravitational pull of matter. This mysterious force continues to intrigue scientists as they seek to understand its nature and implications for the future of the universe. It turns out that not all galaxies have supermassive black holes at their centers. While many large galaxies do host these incredible gravitational phenomena, some smaller galaxies lack them entirely. This fact raises questions about the role of black holes in galaxy formation and evolution, and whether their absence affects a galaxy's development over time. Scientists discovered that while most galaxies contain stars ranging from newly formed to very old, there are galaxies known as green pea galaxies that defy this trend. These small, compact galaxies are so named because of their green appearance in telescope images, and they contain an unusually high number of young stars. They offer a glimpse into the processes that dominated the early universe when star formation was more vigorous. One of my favorite facts is about quasars, which are found at the centers of some galaxies. Quasars are incredibly bright objects powered by supermassive black holes that are actively accreting matter. Despite being billions of light years away, their luminosity can outshine entire galaxies. Their discovery in the mid-20th century revealed the power of black holes and offered insights into the early universe when quasars were more common. Interestingly, the colors of galaxies can tell us a lot about their history and composition. Blue galaxies tend to be rich in young, hot stars, indicating ongoing star formation. In contrast, red galaxies are often composed of older stars, suggesting that their star formation has slowed or stopped entirely. This color coding offers astronomers clues about the life cycles and evolution of galaxies across cosmic time. Here's a fascinating fact about galaxy shapes. The peculiar shape of the Cartwheel galaxy was likely caused by a galactic collision. The ring-like structure resulted from a smaller galaxy passing through a larger one, triggering waves of star formation that give it its distinctive wheel-like appearance. This type of interaction provides a beautiful illustration of the dynamic and ever-changing nature of the cosmos. And finally, consider the concept of galactic cannibalism, a process where larger galaxies merge with and absorb smaller ones. While it might sound like a cosmic horror story, this process is a natural part of the universe's evolution, leading to the growth and transformation of galaxies. Through these mergers, galaxies can acquire new stars, gas, and even dark matter, continuing their complex and intertwined life cycles. As we journey through these galactic mysteries, we're reminded of the vast and interconnected web that forms our universe. Each fact adds a new layer of understanding, like stars filling the night sky, creating a tapestry of discovery and wonder. Let these stories of galaxies both near and far guide your thoughts as you drift further into the peaceful expanse of your imagination. Speaking of the everyday wonders that galaxies bring us, let me share an intriguing fact about a type of galaxy called the ultra-diffuse galaxy. These galaxies are as large as the Milky Way, yet they contain only a fraction of its stars. Some are even so faint that they were only discovered recently, hiding in plain sight despite their vast size. This curious phenomenon has scientists pondering how such massive structures can be so sparsely populated, challenging our understanding of galaxy formation. Interestingly, the smallest known galaxy is a dwarf galaxy named Segway 2, which contains fewer than 1,000 stars. To put this into perspective, the Milky Way has over 100 billion stars. The existence of such minuscule galaxies highlights the diversity found in the universe and prompts questions about the processes that lead to their formation. One curious detail about galaxies involves their rotation. It turns out that the outer regions of galaxies often rotate at the same speed as their inner regions. This observation was one of the first indicators of dark matter's presence, as the visible mass alone couldn't account for the gravitational forces needed to keep these stars moving at such speeds. Here's something unexpected. Some galaxies are known as starburst galaxies because they produce stars at an incredible rate. These galaxies can form stars hundreds of times faster than the Milky Way, driven by factors such as galactic mergers or interactions. Starburst galaxies are windows into the energetic environments of the early universe when star formation was at its peak. Consider this. Galaxies can generate winds that are powerful enough to blow gas out of their own confines. These galactic winds, often driven by supernovae or active galactic nuclei, can influence star formation and even regulate a galaxy's evolution. By pushing gas out, these winds can halt star formation, affecting the future growth and structure of the galaxy. Interestingly, some galaxies appear to be missing a significant amount of dark matter. One such example is NGC 1052, DF2, a galaxy that contains very little dark matter compared to its peers. This discovery is puzzling and has led to discussions about whether our understanding of dark matter and its role in galaxies needs re-evaluation. Speaking of which, there's a phenomenon known as galactic tides, which occurs when the gravitational field of one galaxy stretches and distorts another galaxy. These tides can lead to the formation of tidal tails, which are elongated streams of stars and gas that extend far beyond the main body of the galaxy. These tails provide evidence of past interactions and mergers, offering a glimpse into a galaxy's tumultuous history. You might be surprised to learn that galaxies can be found in places called voids, which are vast regions of space with very few galaxies. These cosmic voids are some of the largest structures in the universe, spanning hundreds of millions of light years. The galaxies that reside in these voids are often isolated and can have unique characteristics due to their solitary existence. One of my favorite galactic phenomena involves the halo of a galaxy. Galactic halos are invisible clouds of hot gas that surround galaxies, often extending far beyond the visible stars. These halos can contain more mass than the galaxy itself and play a crucial role in the galaxy's evolution by providing the material for star formation. Scientists discovered a remarkable feature of galaxies with the phenomenon known as galactic fountains. In these systems, hot gas from star formation and supernovae rises into the halo of a galaxy, cools, and then falls back into the main body of the galaxy. This cyclical process helps regulate star formation and transports heavy elements throughout the galaxy, enriching the interstellar medium. Consider the Lyman alpha blob, a type of enormous structure found in the early universe. These blobs are huge clouds of gas emitting Lyman alpha radiation, a specific type of ultraviolet light. Some of these blobs are larger than present-day galaxies and are believed to be the sites of intense star formation, offering a glimpse into the universe's formative years. Another fascinating aspect of galaxies is the presence of cosmic rays. These high-energy particles originate from stars, supernovae, and other energetic sources within a galaxy. They travel across vast distances and can even reach our planet, providing insights into the processes occurring in distant galaxies and helping us understand the cosmic landscape. Here's something curious. The concept of zombie galaxies describes galaxies that have ceased forming new stars but still contain older, long-lived stars. These galaxies appear red due to their aging star population and can be remnants of past galactic collisions or mergers. The study of zombie galaxies gives us clues about the end stages of galactic evolution. And here's a delightful tidbit about our own Milky Way. It emits a faint glow called the galactic haze. This glow is thought to be caused by energetic particles interacting with the galaxy's magnetic field, creating a diffuse light that spans the entire sky. While not visible to the naked eye, this haze adds to the tapestry of phenomena that make our galaxy so rich and complex. As we continue to unravel the mysteries of galaxies, each discovery, no matter how small or vast, reminds us of the intricate and interconnected fabric of the universe. These everyday wonders, with their seemingly infinite variety, deepen our understanding and appreciation of the cosmos. Let these revelations about galaxies fill your mind with a sense of awe and inspire a restful exploration of the universe's endless possibilities. Galaxies are not just distant objects of light and stars. They are the universe's storytellers, each one with unique tales of creation and evolution. Let me share something interesting about galactic halos. While these halos are typically invisible, some of them emit a type of radiation known as X-rays. This emission comes from the hot gas contained within them, which can be millions of degrees in temperature. Scientists discovered that this hot gas could be a reservoir for elements like iron and oxygen, enriching the galaxy over time. The presence of these elements indicates that the halos play a crucial role in the galaxy's life cycle, helping sustain star formation. Now, consider the phenomenon of cosmic flows. Cosmic flows refer to the large-scale movement of galaxies due to gravitational attractions. These flows can extend across vast regions of space and help us map the distribution of matter in the universe. By studying cosmic flows, astronomers can gain insights into the unseen forces that structure the cosmos. It turns out, these flows are not just random movements, but are intricately connected, forming a pattern akin to a giant cosmic dance. Interestingly, some galaxies contain peculiar objects called globular clusters. These dense groups of stars orbit the outskirts of galaxies like a swarm of bees around a hive. Each globular cluster can contain hundreds of thousands of stars, all bound together by gravity. What makes them particularly fascinating is their age. Many are among the oldest objects in the universe, providing clues about the early stages of galaxy formation. Here's something unexpected. The universe is home to magnetars, which are a type of neutron star with incredibly strong magnetic fields. Some galaxies host these rare and powerful objects, which can have magnetic fields trillions of times stronger than Earth's. When they release energy, it can lead to dramatic and brief bursts of radiation, detectable from millions of light years away. Imagine the power of a magnetar influencing its galactic environment, affecting the stars and matter around it. Another curious detail involves the galactic bulge. This is the central region of a galaxy, often a dense sphere of stars. In spiral galaxies, the bulge can be a nucleus of older stars, contrasting with the younger, more vibrant stars in the spiral arms. The shape and size of a galactic bulge can reveal much about a galaxy's history and how it may have undergone mergers or interactions with other galaxies. Speaking of interactions, some galaxies exhibit a phenomenon known as galactic cannibalism. This occurs when a larger galaxy merges with or absorbs a smaller one. Such mergers can trigger waves of new star formation, as the influx of stars and gas fuels the creation of new stellar generations. These events are not just destructive, they are creative, shaping galaxies and giving rise to new cosmic structures. Delving deeper into the mysteries of galaxies, we find the intriguing concept of galactic rings. These are circular structures of stars and gas, often found in the outer regions of some galaxies. Rings can form due to gravitational interactions, such as when a smaller galaxy passes through a larger one, creating waves that propagate outward. These rings are beautiful reminders of the dynamic and ever-changing universe. Did you know that some galaxies are home to quasars, which are extremely bright objects powered by supermassive black holes? Quasars shine with the light of billions of stars, making them visible across great cosmic distances. The energy they emit can outshine entire galaxies, and they serve as lighthouses, guiding astronomers in their quest to understand the farthest reaches of the universe. Let me share a surprising fact about galactic environments. Galaxies are surrounded by circumgalactic medium. a halo of diffuse gas that extends well beyond the visible stars. This medium acts as a bridge between galaxies and the intergalactic space, playing a vital role in the transfer of matter and the regulation of galaxy growth. By studying this medium, scientists can trace the life cycle of galaxies and their interactions with the cosmic web. Consider the mysterious stellar streams that can be found emanating from galaxies. These streams are the remnants of smaller galaxies torn apart by gravitational forces as they merge with larger galaxies. They weave intricate patterns across the sky, telling stories of past cosmic encounters and providing clues about the history of galactic evolution. Interestingly, the concept of galactic filaments is another example of the universe's interconnected nature. These are massive structures of galaxies and dark matter that form the backbone of the cosmic web. Stretching across millions of light years, filaments connect nodes of galaxy clusters, illustrating the vast scale and complexity of the universe's architecture. Here's something curious about the faintest galaxies, known as ultra-faint dwarf galaxies. These tiny galaxies are incredibly dim, with only a few thousand stars. Despite their small size and low luminosity, they are of great interest to astronomers because they offer a window into the early universe, acting as fossil records of galaxy formation. And here's a delightful fact about galactic illumination. Some galaxies are surrounded by light echoes, which are reflections of light from bright events like supernovae bouncing off interstellar dust. These echoes can illuminate regions of a galaxy long after the initial explosion, allowing astronomers to study the aftermath of these stellar events in detail. As we continue to explore galaxies, each discovery offers a new piece of the cosmic puzzle, unveiling the hidden connections that bind the universe together. These facts not only expand our understanding, but also inspire a deep appreciation for the beauty and complexity of the cosmos. Let the wonder of these discoveries guide you into a peaceful journey through the universe's vast and intricate web. Here's a fascinating detail about the universe's galactic inhabitants. Did you know that some galaxies contain what are known as blue stragglers? These stars are particularly enigmatic because they appear younger and bluer than their surrounding counterparts. One might expect older stars in a dense globular cluster, but these energetic blue stars defy typical age expectations. Scientists believe they form when binary stars merge or when one star siphons material from its companion, rejuvenating itself in the process. This unexpected youthfulness within an ancient setting adds a touch of mystery to the cosmic tapestry. Another captivating phenomenon is the existence of galactic fountains. These dynamic structures are formed by cycles of star formation and supernova explosions. When stars undergo these explosive transformations, they hurl gas and dust into the galaxy's halo, only to have it rain back onto the galactic disk, much like an intricate celestial fountain. This process not only enriches the galaxy with fresh material, but also helps regulate star formation by redistributing essential elements. Consider the intriguing concept of cosmic voids. These are vast, empty spaces between galaxy clusters, making up a large fraction of the universe. Surprisingly, they are not entirely devoid of galaxies. Instead, they host sparse collections of stars and even small, isolated galaxies. These voids provide a unique environment for studying the influence of cosmic structures on galaxy evolution and help scientists understand the large-scale architecture of the universe. Here's something unexpected. Some galaxies host double nuclei, a peculiar feature that can occur when two supermassive black holes are in the process of merging. These dual cores are a remnant of past galactic mergers, and they offer a snapshot of galaxies in the midst of dynamic transformation. The presence of double nuclei provides compelling evidence for the commonality of mergers in galactic history, shedding light on how galaxies grow and evolve over time. Interestingly, some galaxies are distinguished by their polar rings. These are rings of stars and gas orbiting perpendicularly to the main disk of the galaxy. Polar ring galaxies are rare and thought to form through interactions with other galaxies, whether by capturing material or through direct collisions. The study of these peculiar formations helps astronomers understand the complex gravitational dynamics involved in galaxy interactions. It turns out that the universe's largest galaxies, known as CD galaxies, inhabit the centers of galaxy clusters. These colossal elliptical galaxies can span millions of light years and often have extended halos of stars and gas. Their immense size and mass make them gravitational anchors within their clusters, influencing the motion and behavior of surrounding galaxies. The formation of CD galaxies is believed to result from numerous galactic mergers, making them fascinating subjects for studying the hierarchical growth of cosmic structures. Speaking of celestial giants, let's delve into ring galaxies. Known for their striking circular structure, ring galaxies form when a smaller galaxy passes through the center of a larger one. This collision sends ripples through the larger galaxy, creating a ring of stars and gas. These stunning formations offer a visual testament to the dynamic and often violent nature of the universe, illustrating how cosmic interactions can produce breathtaking beauty. And here's a curious detail about tidal dwarf galaxies. These small galaxies arise from the debris of larger galactic interactions. When massive galaxies collide, tidal forces can pull streams of stars and gas into new independent formations. Tidal dwarf galaxies are intriguing because they form from recycled material, providing insights into the processes of galaxy formation and evolution. Interestingly, the Galaxy Zoo is a citizen science project that has engaged thousands of volunteers in classifying galaxies based on their shapes. This collaborative effort has led to significant discoveries, including the identification of rare types of galaxies and patterns that might have been overlooked by professional astronomers. The project highlights the power of community involvement in scientific research and the wealth of knowledge that can be uncovered when many eyes contribute to exploring the universe. One curious detail about galactic dynamics is the phenomenon of galactic tides. Similar to ocean tides caused by the gravitational pull of the Moon on Earth, galactic tides occur when galaxies pass close enough to exert gravitational forces on one another. These interactions can distort their shapes, trigger star formation, and even lead to the exchange of material. Galactic tides serve as reminders of the interconnectedness and constant motion within the cosmic dance. Another intriguing aspect of galaxies is the presence of stellar nurseries, which are dense regions of gas and dust where stars are born. These nurseries are often embedded within molecular clouds, and their study provides a glimpse into the early stages of star formation. Observations of these regions help astronomers understand how stars and planetary systems are forged, offering a window into the processes that lead to the creation of new celestial bodies. You might find it surprising that certain galaxies exhibit anemic spiral arms. Unlike the vibrant star-filled arms of typical spiral galaxies, anemic spirals have faint, less distinct arms and reduced star formation activity. This lack of brightness can be attributed to a deficit of gas, making these galaxies unique in their subdued appearance. Studying anemic spirals can reveal the factors that influence star formation and the diversity of galactic structures within the universe. Lastly, let's explore the halo stars, found in the outer regions of galaxies. These stars are remnants from the early stages of galactic formation, belonging to the oldest population within a galaxy. Unlike stars in the disk, Halo stars have orbits that take them far from the galaxy's center, providing insights into the early conditions of the universe and the processes that shaped galaxies during their infancy. As we continue to unravel these remarkable details about galaxies, each discovery enriches our understanding of the universe and highlights the complex, interconnected web of cosmic phenomena. These facts serve as gentle reminders that the universe is a vast and ever-changing place, inviting us to embark on a continuous journey of exploration and wonder. In the grand tapestry of the cosmos, galaxies exhibit patterns that speak to the profound order and chaos coexisting in the universe. Let me share something unexpected. There exist galaxies whose shapes are influenced by intergalactic winds. These winds, powerful streams of charged particles, can sculpt the gas and dust within a galaxy, leading to intriguing formations. It's a gentle reminder of the invisible forces that craft the visible beauty we observe. Here's a fascinating fact. Some galaxies are known as flocculent spirals. Unlike the classic grand design spirals with well-defined arms, flocculent spirals have a patchy and fragmented appearance. These galaxies challenge our understanding of how spiral arms form and maintain their structure. The varying density of their stellar arms offers insights into the different paths galactic evolution can take. Consider this. Galaxy rotation curves have puzzled astronomers for decades. While the outer regions of many galaxies rotate at speeds similar to their inner parts, as previously mentioned, the intricacies of these curves reveal much about a galaxy's unseen matter. This understanding extends beyond dark matter to include the distribution of baryonic matter, such as stars and gas, shedding light on the gravitational interplay within galaxies. Interestingly, there are galaxies known as luminous infrared galaxies, or LIRGs for short. These galaxies shine incredibly brightly in the infrared spectrum, often due to intense star formation or active galactic nuclei hidden by dust. LIRGs are vital in studying how galaxies evolve and the role of starbursts in galactic life cycles. Their study can illuminate the hidden processes that occur in the dusty, obscured regions of the universe. One curious detail about galaxies is their tendency to form galactic streams. These are elongated structures of stars and gas that extend far beyond a galaxy's main body. Galactic streams often result from gravitational interactions and mergers, leaving behind trails that tell stories of past cosmic encounters. These streams provide a fascinating record of a galaxy's interaction history. It turns out that stellar populations within galaxies can vary considerably. Galaxies often contain stars of different ages, compositions, and histories, contributing to their diverse appearances and behaviors. By studying these populations, astronomers can piece together a galaxy's evolutionary timeline and uncover the secrets of star formation and death within its borders. Here's something curious. Some galaxies contain regions where stars appear to be inverted. Known as stellar inversion zones, these areas show stars with unusual motion patterns, sometimes appearing to move opposite to the majority of the galaxy. Such anomalies often arise from gravitational perturbations, offering a window into the complex dynamical environments within galaxies. Did you know that galaxies sometimes have counter-rotating disks? In these intriguing systems, gas or stars in the central regions rotate in the opposite direction to those in the outer zones. This peculiar phenomenon can occur due to past mergers or accretion events, hinting at the chaotic processes that shape galactic structures over time. Here's a surprising tidbit. Certain galaxies exhibit warped disks. These are galaxies where the disk is not flat, but instead twisted or bent, often due to gravitational interactions with nearby objects. Warped disks provide insights into the gravitational forces at play in galactic environments and the interactions that induce these warped formations. Interestingly, galactic conformers are galaxies that resemble each other in structure and composition because they formed under similar conditions. These siblings of the cosmos challenge our understanding of galactic diversity and the factors leading to their uniformity. Studying conformers helps astronomers identify the common threads in galactic formation and evolution. One of my favorite facts involves galactic fountains, where gas and dust are expelled from the galaxy's core only to rain back down over time, feeding ongoing star formation. This cyclical process maintains the dynamic equilibrium within galaxies, highlighting the interplay between energy release and material recycling. Consider this. Some galaxies are polarized. These are often radio galaxies, emitting polarized light that reveals the magnetic fields threading through their cores and jets. The study of polarization in galaxies offers clues about magnetic field structures and their role in energy transfer within the cosmos. Lastly, let's explore the concept of galactic blending. This occurs when galaxies in close proximity share material, leading to diffuse boundaries and blended features. Galactic blending reveals the porous nature of galaxy edges and the interactions that blur the lines between distinct cosmic entities. As you reflect on these captivating aspects of galaxies, you can appreciate how they form larger cosmic patterns, each contributing to the grand narrative of the universe. These insights allow us to ponder not just the vastness of space, but the intricate dance of forces that give rise to the celestial wonders we see in the night sky. Let us delve into some lesser-known truths about galaxies that might just surprise you. For starters, consider the green pea galaxies. These are small, compact galaxies that emit a bright green glow. Discovered by citizen scientists in 2007, their unusual color is due to the intense ionization of oxygen within them. Their appearance sheds light on the processes happening during the early universe, when galaxies were much younger and more turbulent. Speaking of unique galactic characteristics, you might be intrigued to learn about galactic cirrus. It consists of wispy clouds of interstellar dust found in the Milky Way. Under certain conditions, these clouds are visible as faint, diffuse light when observed in the night sky. They appear like delicate veils, contributing to the ethereal beauty of the cosmos and offering insights into the material that drifts between stars. Here's something unexpected. Certain galaxies are known to have stellar mortuaries. These are regions where massive stars have ended their lives in spectacular supernovae, leaving behind remnants like neutron stars or black holes. These remnants create a unique environment rich in heavy elements, which can later be recycled into new generations of stars. It is a poignant reminder of the cyclical nature of galactic evolution, where endings pave the way for new beginnings. Interestingly, galaxies can also be home to phenomena known as galactic rings, but not in the way you might think. Such rings are regions of active star formation that encircle the galaxy's core. They are often triggered by gravitational interactions, such as the presence of a nearby companion galaxy. These rings are like cosmic nurseries where new stars are born, offering a window into the dynamic processes that fuel galactic life. Did you know that some galaxies are part of what astronomers call dark galaxies? These are galaxies that contain very few stars and mostly consist of gas and dark matter. Because they emit little light, they are challenging to detect. Dark galaxies are thought to represent an early stage of galaxy formation, providing clues about how galaxies acquire their mass and develop over time. Speaking of galactic wonders, you might find it fascinating that there are jellyfish galaxies, named for their tentacle-like streams of stars and gas. These galaxies are typically found in galaxy clusters. The unique formation of the jellyfish's appendages is a result of a process called ram pressure stripping, where the galaxy moves through the hot, dense gas of a cluster, stripping away its own material. This process is both destructive and creative, as it can also trigger bursts of new star formation. Now let's talk about something truly remarkable: the phenomenon of galactic cannibalism. Unlike the typical image of a galaxy devouring another in a colossal merger, galactic cannibalism often involves a larger galaxy slowly stripping away and absorbing the material of a smaller companion over time. This gradual consumption leads to the growth and evolution of the larger galaxy, showcasing the dynamic and sometimes predatory nature of cosmic interactions. Consider the concept of galactic reefs. Much like coral reefs on Earth, these are regions within galaxies that are rich in gas and dust, supporting a variety of star formation activities. These reefs can be highly productive areas where new stars are born, nurtured by the surrounding material. Galactic reefs underscore the interconnectedness of cosmic ecosystems and the ongoing cycle of birth and death within the universe. Here's a curious detail. Some galaxies contain cosmic jelly. Unlike its name, cosmic jelly refers to the faint, diffuse light emitted by intracluster stars, stars that are not bound to any single galaxy but roam freely within a galaxy cluster. This light creates a soft glow, like a cosmic jelly surrounding the cluster, offering clues about the history of galaxy interactions and mergers within the cluster. It turns out that galaxies can also host galactic geysers. These are massive outflows of gas that are ejected from the central regions of a galaxy, often driven by activity from a supermassive black hole or bursts of star formation. Galactic geysers play a crucial role in regulating the growth of galaxies by expelling material that could otherwise form new stars. They act as a feedback mechanism, balancing the inflow of new material with the outflow of energy and matter. Another surprising truth involves galactic filaments. These are vast, thread-like structures that connect galaxies across cosmic distances, forming part of the larger cosmic web. Galactic filaments are primarily composed of dark matter and gas, serving as cosmic highways for galaxies and matter to flow along. They illustrate the intricate and grand architecture of the universe, revealing how galaxies are not isolated islands but part of a vast, interconnected network. Here's something to ponder: the existence of fossil galaxies. These are galaxies that have remained relatively unchanged for billions of years, offering a glimpse into the conditions of the early universe. Studying fossil galaxies helps astronomers understand how galaxies have evolved over cosmic time and what factors contribute to their longevity and stability. Lastly, let's explore the notion of galactic ripples. These are wave-like disturbances that propagate through the disk of a galaxy, similar to ripples on a pond. Galactic ripples can be triggered by interactions with other galaxies or by internal processes, leading to waves of star formation as they move through the galaxy. These ripples highlight the dynamic and ever-changing nature of galaxies, where even small perturbations can have significant effects over time. As we reflect on these surprising truths about galaxies, you might begin to see how they weave a complex narrative of cosmic evolution. Each fact tells a story of how galaxies form, interact and transform, enriching our understanding of the universe as a whole. Such insights remind us of the vastness of space and the interconnected dance of forces that create the celestial wonders we observe in the night sky. Here's something unexpected. While galaxies are often thought to be vast collections of stars, dust, and gas, some also harbor vast numbers of rogue planets. These planets wander the galaxy without orbiting a star, like cosmic nomads journeying through the interstellar medium. Scientists estimate there could be billions of these free-floating planets in our Milky Way alone, challenging our traditional ideas of planetary systems. And speaking of challenges, consider this. Some galaxies possess supervoids. These are enormous, empty expanses within the cosmic web that can stretch across hundreds of millions of light-years. Supervoids are not completely devoid of matter, but they contain significantly fewer galaxies compared to other regions, making them mysterious and somewhat eerie realms in the vastness of space. Interestingly, not all galaxies are composed of the same kinds of stars. For example, some rare galaxies, called low-surface brightness galaxies, primarily consist of dim stars that make them difficult to detect with traditional telescopes. These galaxies are sparsely populated and can offer insights into the dark matter that holds them together, as their faint nature suggests a heavy reliance on this unseen mass. In the realm of galactic oddities, there's a phenomenon known as galactic conformism. It's a curious detail where galaxies within a cluster tend to have similar properties, like color and star formation rates. This similarity is thought to arise from the shared environment and interactions, showing how galactic communities can influence individual members over time. Here's something that might surprise you. Galaxies have been known to exhibit galactic lopsidedness. This asymmetry can manifest as an uneven distribution of stars or gas, often due to gravitational interactions or past cosmic encounters. Such lopsidedness provides clues about a galaxy's history and the forces that have shaped it. Another fascinating aspect of galactic behavior is found in galactic flares. These flares occur when material falling into a galaxy's central black hole causes sudden bursts of radiation. Such flares can illuminate the surrounding environment, revealing details about the galaxy's core processes and the dynamics at play in these often hidden regions. Consider the intriguing case of galactic ghost light. This faint glow emanates from stars that have been stripped from their host galaxies during interactions. The resulting light forms a dim halo around galaxy clusters, offering a spectral reminder of past galactic encounters and the ongoing dance of cosmic matter. You might find it intriguing that some galaxies are home to galactic fountains which cycle gas and dust in peculiar ways. These fountains can spur new star formation, creating vibrant pockets of activity within otherwise calm regions. This cyclical process highlights the renewal and ongoing evolution within galaxies, where even the most tranquil areas can harbor dynamic life cycles. In the cosmic theater, there are also galactic masquerades, where galaxies disguise themselves as other types. For instance, an elliptical galaxy might appear to be a spiral one due to the orientation of its dusty lanes or the angle at which we view it. These masquerades illustrate the challenges astronomers face in classifying and understanding the true nature of celestial objects. One curious fact involves galactic sound waves. These are not sounds as we experience on Earth, but ripples in the gas and dust within galaxies, akin to sound waves traveling through air. These cosmic vibrations can trigger star formation and are a testament to the living, breathing nature of galaxies. And here's something truly extraordinary. Some galaxies are considered zombie galaxies. These galaxies have ceased new star formation due to exhausted gas supplies, yet they continue to exist for billions of years. They serve as a haunting reminder of the eventual fate that might await even the most active galaxies, as well as the endurance of cosmic structures. Speaking of longevity, let's touch on ancient stars found within many galaxies. These stars date back to the early universe and provide a living record of the conditions that existed shortly after the Big Bang. The presence of ancient stars helps astronomers piece together the puzzle of galaxy formation and evolution over cosmic time. In the world of galactic phenomena, There's also the concept of galactic mirages. These optical illusions are caused by gravitational lensing, where the light from a distant galaxy is bent around a massive object, such as another galaxy or galaxy cluster. This bending can create multiple images of the same galaxy, magnifying and distorting them like a funhouse mirror in space. Lastly, consider the intriguing galactic tidal tails. These elongated streams of stars and gas are pulled from galaxies during close encounters with others. Tidal tails can extend for millions of light years, showcasing the gravitational pull at work in these cosmic interactions and leaving a trail of stellar breadcrumbs that narrate the story of galactic dances. Reflecting on these captivating facts, it's clear that galaxies are not just static collections of stars, but dynamic entities with intricate stories shaped by interactions, environments, and time. They remind us of the complex tapestry of the universe, woven together by threads both seen and unseen. As you let these thoughts sink in, you might feel a deeper connection to the cosmos, knowing that each galaxy, with its unique character and history, adds to the grand narrative of our universe. Gazing deeper into the cosmos, let's delve into the remarkable phenomenon of galactic bridges. These are connections of gas and stars that form between galaxies, especially those in close proximity. Galactic bridges are often the result of gravitational interactions between neighboring galaxies. Imagine two cosmic giants so close that their gravitational forces pull on each other, stretching streams of matter across the vast intergalactic space. These ethereal bridges not only create a visual spectacle, but also play a key role in the transfer of material, potentially influencing star formation in both galaxies. In some cases, these bridges can become stable pathways for stars and gas to travel from one galaxy to another. This exchange of material can significantly alter the evolutionary paths of the galaxies involved. The phenomenon of galactic bridges reminds us of the delicate balance and complex interactions inherent in the universe's architecture. The forces at play are invisible, yet their impact is unmistakable, guiding the flow of matter in a cosmic dance. Speaking of dances, let's explore the concept of galactic harmonics. Imagine the construction of a symphony where every instrument must align with the others to produce a harmonious sound. This is observed in the way their rotational velocities tend to synchronize with the gravitational pull of neighboring galaxies and the filaments of the cosmic web. It's as if galaxies in clusters participate in a grand cosmic orchestra, their movements determined by the unseen hand of gravitational forces. This interplay affects how galaxies evolve over time, with each participant subtly influencing its neighbors. Galactic harmonics provide insights into the structure and distribution of galaxies within the universe, emphasizing the interconnectedness of all things. It's a reminder that even the most distant galaxies are not isolated entities but part of a greater cosmic community. Turning our attention to the enigmatic light echoes, we find another fascinating galactic phenomenon. Light echoes occur when light from a distant event, such as a supernova, is scattered by interstellar dust, creating delayed reflections. Imagine witnessing the light from a star that exploded thousands or even millions of years ago, its luminosity bouncing off cosmic dust clouds like ripples on a pond. This phenomenon allows astronomers to study past events as if they're happening in real time, providing a unique window into the history of galaxies. Light echoes reveal not only the dynamic processes within galaxies, but also the composition of the interstellar medium. They can offer clues about the types of dust present and the distances involved, enriching our understanding of the galaxy's past. The echoes serve as ghostly reminders of the vibrant and sometimes violent histories of galaxies that continue to unfold over cosmic timescales. Now, let's delve into the intriguing world of galactic resonances. These occur when gravitational forces cause stars or gas in a galaxy to orbit in synchrony with the galaxy's overall rotation. It's akin to an invisible conductor directing an orchestra, where certain frequencies resonate more strongly, leading to patterns or structures like spiral arms. These resonances can lead to regions of enhanced star formation or areas where gas and stars become more densely packed. Galactic resonances highlight the importance of gravity in shaping galaxy structures, demonstrating how subtle forces can lead to large-scale changes over time. They also illustrate the dynamic nature of galaxies, constantly evolving and responding to internal and external influences. In the grand scheme of things, these resonances are part of the mechanisms that ensure galaxies remain vibrant and full of life. In the midst of these cosmic wonders, there's the captivating phenomenon of galactic tides. Similar to how the moon influences the Earth's oceans, massive galaxies exert tidal forces on their surroundings. These forces can stretch and compress neighboring galaxies, leading to structural changes and sometimes even triggering bursts of star formation. Galactic tides are a testament to the power of gravity, capable of molding galaxies into new forms and altering their trajectories through the universe. Such interactions underscore the interconnectedness of galaxies, each one influencing and being influenced by its neighbors. Galactic tides remind us that the universe is a dynamic, ever-changing environment, where forces from the largest to the smallest scales interact to shape the cosmos. Through these tidal interactions, galaxies reveal their histories and future potentials, with each ripple in the cosmic ocean telling a story of gravitational interplay. Another intriguing aspect of galactic dynamics is the concept of galactic feedback. This involves the processes by which galaxies regulate their environments, often through the energy and matter expelled by events like supernovae or active galactic nuclei. These feedback loops can either promote or inhibit star formation, depending on the conditions within the galaxy. It's a self-regulating system where galaxies manage their resources, influencing their own evolutionary paths. Galactic feedback highlights the complexities of galactic ecosystems, where each event contributes to the overall health and longevity of the galaxy. By understanding these feedback mechanisms, astronomers gain insights into the life cycles of galaxies and how they maintain balance amidst the chaos of the universe. It serves as a reminder that galaxies are not merely collections of stars, but sophisticated systems with intricate processes at play. In the vastness of space, galaxies are not only shaped by internal forces, but also by the cosmic environment. One such environmental influence is the presence of galactic filaments. These are long, thread-like structures composed of dark matter and gas that stretch across the universe, forming the scaffolding upon which galaxies are assembled. Galaxies located along these filaments often align with the filament's direction, a testament to the gravitational forces at work. Galactic filaments are the highways of the universe, channeling matter and energy between galaxies and clusters. By studying these structures, scientists can gain a deeper understanding of the universe's large-scale structure and the role dark matter plays in galaxy formation and evolution. They also illustrate the interconnectedness of all cosmic structures, revealing the hidden framework that supports the visible universe. Reflecting on these intricate phenomena, it's clear that galaxies are far more than simple collections of stars. They are dynamic, interactive entities, each telling a unique story of creation, evolution, and interaction. As we continue to explore and learn from these galactic wonders, we gain not only a greater understanding of the universe, but also a deeper appreciation for the complex tapestry of reality. In this journey of discovery, every galaxy, with its unique character and history, enriches the larger narrative of our cosmic existence. Continuing our journey through the captivating cosmos, let's explore the rich tapestry of historical perspectives that have shaped our understanding of galaxies. It's intriguing to consider just how far humanity's grasp of these celestial behemoths has come. Early astronomers, peering through rudimentary telescopes, could never have imagined the vast and complex structures we know today as galaxies, yet their contributions laid the groundwork for modern discoveries. One of the pivotal moments in the history of astronomy was the work of the philosopher Immanuel Kant in the 18th century. Kant proposed that the Milky Way was not the entirety of the universe, but rather one of many island universes scattered throughout the cosmos. This was a revolutionary idea at the time, challenging the prevailing notion that our galaxy was the sole structure in an otherwise empty universe. Kant's hypothesis sparked debate and intrigue, gradually leading scientists to expand their view of the universe. Fast forward to the early 20th century, and we find the pioneering work of Vesto Melvin Slipher. Through painstaking spectroscopic observations, Slipher measured the velocities of spiral nebulae, now known as galaxies, discovering that many were receding from the Earth at remarkable speeds. This work provided crucial evidence for the expanding universe, a concept later built upon by others. Slipher's findings added a vital piece to the cosmic puzzle, suggesting that galaxies were not static but dynamic entities moving through space. An equally fascinating chapter in the history of galactic discovery involves the development of photographic plates in the late 19th and early 20th centuries. These technological advancements revolutionized astronomy, allowing astronomers to capture the faint light of distant galaxies. This new ability to photograph the heavens enabled astronomers to catalogue and study galaxies in greater detail, gradually revealing the intricate structures and varied forms these cosmic giants take. The photographic records contributed immensely to the mapping of the cosmos and the classification of galaxies based on their shapes and sizes. The classification of galaxies owes much to a figure often mentioned in the history of astronomy, Edwin Hubble. However, Hubble wasn't the first to attempt this task. Before him, the astronomer William Parsons, the third Earl of Rosse, had observed and sketched several nebulae in the mid-19th century using his large telescope, the Leviathan of Parsonstown. His work hinted at the spiral structures within these nebulae, which we now recognize as galaxies. Though limited by the technology of his time, Parsons provided valuable observations that would later be revisited and expanded upon with greater precision. While much of our understanding of galaxies stems from observations in visible light, it's important to note the contributions of radio astronomy to the field. In the mid-20th century, radio telescopes opened a new window to the cosmos, allowing astronomers to detect radio waves emitted by galaxies. This approach unveiled previously hidden aspects of galactic structures, such as vast clouds of hydrogen gas and the energetic phenomena occurring in their cores. Radio astronomy has played a significant role in our understanding of galaxies, offering insights that are simply not possible with optical telescopes alone. Speaking of which, one particularly interesting example of radio astronomy's impact is the discovery of quasars. These extraordinarily luminous objects are powered by supermassive black holes at the centers of distant galaxies. Quasars were first identified as strong radio sources, and only later were they linked to the optical counterparts that appear as star-like points of light. The study of quasars has provided valuable information about the early universe and the life cycles of galaxies, highlighting the dynamic and energetic processes occurring within them. Another remarkable tool in the astronomer's toolkit is spectroscopy. This technique involves analyzing the light from galaxies to determine their composition, temperature, density, and motion. By spreading out the light into its constituent colors, or spectrum, astronomers can identify the chemical elements present in a galaxy and deduce a wealth of information about its stars and gas. Spectroscopy has proven essential in measuring redshifts, which indicate how fast galaxies are moving away from us, further supporting the idea of an expanding universe. As we reflect on these historical advancements, it's clear that our journey to understand galaxies is a testament to human curiosity and ingenuity. Each technological breakthrough and each philosophical leap has added depth to our view of the universe, transforming once distant and mysterious objects into intricate systems that we can explore and comprehend. The story of galactic exploration is a continuous thread in the tapestry of human discovery, connecting past achievements with future possibilities. In this ongoing exploration, the role of collaboration cannot be overstated. The study of galaxies has been, and continues to be, a global endeavor. Scientists from diverse backgrounds and countries contribute their unique perspectives and skills, pooling resources and expertise to tackle the mysteries of the universe. This spirit of cooperation is exemplified by international projects such as the Large Synoptic Survey Telescope, which will provide unprecedented views of the sky and improve our understanding of galactic evolution. Considering the vastness of the universe and the relatively short span of human history, it's humbling to see how much we have learned about galaxies in such a brief period. We've moved from viewing them as distant, unchanging points of light to understanding them as dynamic, interactive systems with complex life cycles. Each discovery brings with it a sense of wonder and prompts new questions, propelling us further on our cosmic journey. As we continue to unravel the mysteries of galaxies, we are reminded of the interconnectedness of all things. The study of galaxies not only informs us about the universe, but also about our place within it. We are part of this grand cosmic tapestry, made of the same elements that fuel stars and create galaxies. This connectedness fosters a sense of belonging and encourages us to cherish the beauty and complexity of the universe. In this gentle exploration of galactic history, we can take solace in knowing that our quest for knowledge is a shared human experience, one that transcends boundaries and unites us in a common pursuit of understanding. As we gaze up at the night sky, we are part of a continuum of explorers, each contributing to the story of the cosmos in their own way. This realization enriches our appreciation for the universe and invites us to continue our journey with open minds and open hearts. The story of how galaxies have been perceived throughout human history is as varied as the stars themselves. While we now understand galaxies as vast collections of stars, gas, and dark matter, ancient cultures had their own interpretations of these mesmerizing celestial objects. In many traditions, the Milky Way was often viewed as a bridge or a pathway. For instance, the Greek mythology spoke of it as the milk of Hera, the goddess, spilling across the sky. Meanwhile, in some indigenous Australian cultures, the Milky Way was seen as the river of the sky, its stars being campfires of ancestral spirits. These interpretations, rich with cultural significance, show how galaxies have inspired human imagination for millennia. In more recent times, galaxies have found their place in art and culture beyond myth and legend. The swirling forms of galaxies, like those captured in images from the Hubble Space Telescope, have inspired countless artists. Their depictions appear in paintings, digital art, and even fashion. The spiral arms in particular have become symbols of infinity in creation, reflecting the endless possibilities and the ever-changing nature of the universe. Just as artists have drawn inspiration from galaxies, so too have poets. Galaxies often serve as metaphors for exploration and the unknown, evoking feelings of wonder and curiosity. Their vastness mirrors the human quest for knowledge and discovery. Music, too, has been touched by the allure of galaxies. Composers have sought to capture the majesty of the cosmos in symphonies and orchestral pieces, using galaxies as inspiration for their melodic structures. The grandeur of a spiral galaxy's arms spiraling outward can be akin to a musical crescendo, building anticipation and awe. In literature, authors have long been drawn to the enigmatic nature of galaxies. They use them as settings for stories that explore humanity's place in the cosmos, or as symbols of the infinite possibilities and the mysteries that lie beyond our understanding. Science fiction in particular has capitalized on the concept of galaxies, using them as backdrops for tales of alien civilizations, space travel, and intergalactic empires. The idea of different galaxies harboring diverse forms of life and civilizations ignites the imagination, allowing storytellers to explore themes of unity and diversity on a cosmic scale. These narratives remind us of the endless potential that the universe holds, a playground for both the mind and the heart. Speaking of unity, the study of galaxies itself is a testament to the collaborative efforts of humanity. Across the globe, scientists work in tandem, sharing data, resources, and insights. This spirit of cooperation is evident in projects like the Large Synoptic Survey Telescope, where countries from around the world have come together to build a tool that will deepen our understanding of the universe. Such international collaborations highlight how the study of galaxies transcends borders, uniting us in the common pursuit of knowledge and discovery. Beyond collaboration, there's a personal dimension to our relationship with galaxies. Standing under a starry sky, one can't help but feel a profound connection to the universe. This act of stargazing can evoke a deep sense of belonging as you realize that the atoms in your body were once forged in the hearts of stars. This connection, often expressed in the phrase "star stuff," popularized by Carl Sagan, emphasizes that we are all part of this grand cosmic tapestry. The universe, with its galaxies, serves as a reminder of our shared origins and our place in the vast expanse of space. Galaxies also play a role in expanding our perspective. They challenge us to think beyond the confines of our daily lives, to consider the bigger picture. The sheer scale and number of galaxies, with estimates suggesting over 2 trillion in the observable universe, are humbling. They urge us to contemplate the nature of existence, the evolution of the cosmos, and the future of space exploration. In doing so, they inspire a sense of wonder and curiosity, driving us to explore the unknown and to seek answers to the most profound questions. The philosophical implications of galaxies are profound. They invite us to reflect on the cyclic nature of the universe. Just as stars are born, live, and die, so too do galaxies. They collide, merge, and evolve over billions of years. This cycle of birth, transformation, and renewal mirrors the cycles we observe in life on Earth, inviting us to consider the interconnectedness of all things. This perspective fosters a sense of appreciation for the complexity and beauty of the universe, encouraging us to cherish each moment and to marvel at the wonders around us. Galaxies, with their mesmerizing beauty and complexity, captivate us not only because of what they are, but also because of what they represent. They are symbols of the infinite, of the vastness of space and time, and of the mysteries that continue to elude us. They challenge us to think creatively, to question our assumptions, and to seek new ways of understanding the world. In this way, galaxies serve as a bridge between science, art, and philosophy, inviting us to explore the universe with open minds and open hearts. As we continue to explore galaxies, we're reminded of the enduring power of curiosity and the human spirit. Each new discovery, each new insight adds a piece to the puzzle of the cosmos, bringing us one step closer to understanding the universe and our place within it. This journey is one of shared experience, of collaboration and innovation, and of a profound connection to the stars. It's a testament to our capacity for wonder and the endless possibilities that lie ahead as we chart our course through the great expanse of space. Speaking of the future, the universe's endless possibilities prompt us to consider the eventual fate of galaxies themselves. One area of interest is the role of gravitational waves in the evolution of galaxies. These ripples in space-time, predicted by Albert Einstein over a century ago, are generated during cataclysmic events, such as the collision of black holes and neutron stars. Imagine the tremendous impact these waves have as they travel across the vastness of space, potentially influencing the structure and dynamics of galaxies they pass through. The detection of gravitational waves has opened new doors in understanding the universe's behavior, allowing us to observe cosmic events that were once invisible to us. Gravitational waves may also reveal hidden details about galaxy mergers. When two galaxies collide, their central black holes are expected to eventually merge as well, releasing powerful gravitational waves. This process offers clues about the frequency of such mergers and the resulting transformations of galactic cores. With advancements in technology, scientists hope to detect these signals more frequently, providing insights into the formation and evolution of galaxies. It's a marvel to think about the intricate dance of galaxies over billions of years, choreographed by the unseen force of gravity. In addition to gravitational waves, the concept of panspermia offers an intriguing perspective on the potential for life beyond Earth. This hypothesis suggests that life can spread throughout the universe via space dust, meteoroids, and comets, potentially seeding young planets with the building blocks of life. Imagine the possibility that microbial life could travel across galaxies, carried by cosmic winds or within rocky debris. This raises profound questions about the origins of life on Earth and the potential for life on other planets. Are we, in fact, cosmic travelers, our origins intertwined with the stars? The study of extremophiles, organisms that thrive in Earth's harshest environments, supports the idea that life could exist in the seemingly inhospitable conditions of space. These resilient life forms have spurred scientists to consider that similar organisms might survive the journey across the void, eventually flourishing on distant worlds. This prompts us to rethink our understanding of life itself, extending the potential for biological diversity well beyond the confines of our own planet. As we contemplate these cosmic journeys, the concept of the multiverse adds another layer of complexity to our understanding of galaxies. The multiverse theory posits that our universe is just one of many, each with its own unique properties and laws of physics. If true, this suggests that galaxies in other universes could be vastly different from those we know. They might have alternative structures, compositions, or evolutionary paths, challenging our perceptions of what is possible. This tantalizing prospect broadens our horizons and invites us to consider the infinite variations of existence. The multiverse concept also challenges our philosophical understanding of reality. If there are countless universes, each with its own version of events, what does this mean for our sense of self and place in the cosmos? It encourages us to think about the interconnectedness of all things, transcending the boundaries of our known universe. This idea invites a sense of humility and wonder as we ponder the vastness of creation and the potential for infinite diversity. Another fascinating aspect of galaxies is their potential role in shaping cosmic weather. Just as Earth's weather is influenced by solar activity, galaxies can be affected by cosmic events such as supernovae and gamma-ray bursts. These energetic phenomena can release vast amounts of radiation, impacting the magnetic fields of galaxies and possibly altering their star formation rates. The study of cosmic weather patterns helps us understand the dynamic and ever-changing nature of galaxies, emphasizing their interconnectedness with the broader universe. The dynamics of galaxies also raise intriguing questions about the nature of time. In the vast scales of the cosmos, time becomes a fluid concept, stretching and warping under the influence of gravity. As we observe distant galaxies, we are peering into the past, seeing light that has traveled for millions or even billions of years. This cosmic time travel offers a glimpse into the universe's history, allowing us to witness the life cycles of stars and galaxies as they unfold across the eons. Reflecting on these themes, one can't help but feel a deep sense of awe and wonder at the universe's complexity and beauty. Galaxies, as both physical entities and symbols, push the boundaries of our understanding and imagination. They serve as a reminder of humanity's enduring curiosity and our capacity to explore the unknown. Each discovery, each new insight, fuels our desire to learn more about the cosmos and our place within it. As we gaze at the night sky, we are reminded of the profound connections between all things. The atoms that compose our bodies were forged in the hearts of ancient stars, linking us to the universe in an intimate and meaningful way. This realization fosters a sense of unity, encouraging us to cherish the world around us and to marvel at the mysteries that remain. In this way, galaxies inspire us to embrace the unknown, to seek out new knowledge, and to find joy in the journey of discovery. The future of galactic exploration is bright, with new technologies and collaborations paving the way for deeper insights into the universe's secrets. As we continue to unlock the mysteries of galaxies, we are reminded of the boundless potential of human ingenuity and the spirit of exploration that drives us forward. With each new breakthrough, we come one step closer to unraveling the tapestry of the cosmos and understanding the intricate dance of galaxies across time and space. This ongoing quest is a testament to our shared commitment to knowledge. It underscores the importance of collaboration and the exchange of ideas, bringing together diverse perspectives and expertise to tackle the challenges of understanding the universe. As we look to the future, we are filled with anticipation and excitement, knowing that the wonders of galaxies will continue to inspire and captivate us for generations to come. In contemplating the vastness of space and the mysteries of galaxies, we find a source of inspiration and wonder. This journey through the cosmos invites us to expand our horizons, to question our assumptions, and to explore the infinite possibilities that await us. As we chart our course through the stars, we are reminded of the beauty and complexity of the universe and the profound connections that bind us all. Our journey into the mysteries of galaxies invites us to explore the interconnectedness of celestial bodies and the intricate web of interactions that shape the universe. One intriguing aspect of galaxies is their role in the cosmic recycling of matter. Galaxies are not isolated entities. They are dynamic, bustling environments where matter is continually being transformed. New stars are born from the remnants of older ones, suggesting a grand cycle of stellar evolution. This recycling process is crucial for maintaining the balance of elements necessary for life as we know it. It's a celestial cycle reminiscent of the cycles of life on Earth, where birth and death feed into one another, sustaining the larger ecosystem. The notion of galactic recycling brings us to the fascinating concept of galactic winds. These powerful outflows, driven by supernovae and active galactic nuclei, can push gas and dust out of galaxies, sometimes even into intergalactic space. As these winds travel vast distances, They seed neighboring galaxies with the materials needed for star formation, contributing to the cosmic web's continuous evolution. This intergalactic exchange prompts us to consider the universe as a colossal, interconnected organism constantly reshaping itself. It's a humbling thought, realizing that the elements that make up our own planet might have traveled across unimaginable distances carried by these cosmic winds. Speaking of cosmic distances, consider the concept of gravitational lenses. This phenomenon occurs when a massive object, like a galaxy cluster, bends and magnifies the light from more distant galaxies behind it. This natural cosmic lens allows astronomers to peer deeper into the universe, revealing galaxies that are otherwise too faint to see. Gravitational lenses act as nature's telescopes, enabling us to observe the universe's infancy and the formation of the earliest galaxies. This insight into the past challenges us to think about the scale of time and space, where light from the farthest reaches might take billions of years to reach us, offering a glimpse into the universe's early days. Galaxies also teach us about the universe's vast tapestry through the intriguing notion of cosmic filaments. These colossal structures, composed of galaxies and dark matter, stretch across the universe like the threads of a cosmic web. They serve as the scaffolding upon which galaxies are built and interact. These filaments create pathways for matter to travel and congregate, influencing the formation and evolution of galaxies. Understanding these filaments broadens our perspective on how the universe is structured and the forces that govern its expansion and development. It's as though the universe itself is a grand interconnected artwork, with each filament contributing to the larger masterpiece. While the cosmic web connects galaxies on a vast scale, the influence of individual galaxies on their environment can be equally profound. Some galaxies, known as radio galaxies, emit powerful radio waves from their central regions, often due to supermassive black holes. These radio waves can extend over millions of light years, influencing the intergalactic medium and even triggering star formation in other galaxies. This unexpected influence underscores the power of galaxies to shape their surroundings, acting as cosmic beacons in the vastness of space. The exploration of galaxies also leads us to ponder the concept of cosmic archaeology. Just as archaeologists unearth the history of ancient civilizations through artifacts, astronomers study galaxies to uncover the history of the universe. By observing galaxies of different ages, scientists piece together the sequence of events that have shaped the cosmos. This approach allows us to trace the universe's evolution from its early moments to the formation of complex structures like galaxies. It's a quest that not only reveals the universe's secrets, but also deepens our appreciation for the intricate dance of creation and destruction that has unfolded over billions of years. As we delve further into the wonders of galaxies, the phenomenon of starburst galaxies emerges as a captivating subject. These galaxies experience intense periods of star formation, producing new stars at rates hundreds of times faster than typical galaxies. Starburst activity is often triggered by interactions or mergers with other galaxies, leading to dramatic changes in their structure and dynamics. This rapid star formation enriches the galaxy with heavy elements, literally altering its composition in cosmic moments. Such galaxies remind us of the universe's ability to transform and adapt, showcasing the dynamic processes that continue to shape its evolution. Interestingly, the study of galaxies even extends to their interaction with cosmic rays. These high-energy particles, originating from supernova explosions and other energetic processes, permeate galaxies and influence the processes within. Cosmic rays can play a role in cloud formation within galaxies by ionizing gas and dust, impacting star formation rates. This subtle yet significant interaction highlights the complex interplay between the various components of galaxies and the broader universe. It's a reminder that even the smallest particles can have profound effects on the grand cosmic scale. Reflecting on these diverse aspects of galaxies, one can't help but marvel at the universe's complexity. Each discovery unveils another layer of cosmic beauty, encouraging us to deepen our understanding of the vast universe we inhabit. Galaxies serve as a testament to the universe's endless creativity, inviting us to explore, learn, and imagine the infinite possibilities that lie beyond. They inspire us to dream of new frontiers, pushing the boundaries of our knowledge and challenging us to embrace the unknown. As we continue to unravel the mysteries of galaxies, we are reminded of our own place in the cosmos. The atoms that compose our bodies, the air we breathe, and the world we call home are all part of this grand cosmic narrative. This profound connection invites us to cherish not only our planet, but also the vast universe that surrounds us. It encourages us to look up at the night sky with a sense of wonder and gratitude, knowing that we are part of something far greater than ourselves. In contemplating galaxies, we find a source of endless wonder and inspiration. They invite us to explore the depths of our imagination, to question the nature of existence, and to embrace the mysteries that remain. As we gaze at the stars, let us hold on to this sense of curiosity and wonder, allowing it to guide us on our journey through the cosmos. As we continue our exploration of galaxies, the fascinating concept of galactic halos emerges, offering an intriguing glimpse into the less visible parts of these cosmic structures. Galactic halos are vast, roughly spherical regions surrounding galaxies, composed primarily of dark matter and a sparse population of stars. They extend far beyond the visible edges of a galaxy, often enveloping it in a mysterious, unseen aura. These halos are crucial for understanding galaxy formation and dynamics, because their gravitational influence affects the motion of stars within the galaxy. One of the most fascinating aspects of galactic halos is their role in solving the mystery of missing baryonic matter. Baryonic matter, which makes up stars, planets, and all visible structures, accounts for only a fraction of the universe's mass. Yet there remains a significant amount of baryonic matter unaccounted for in the observable universe. Galactic halos might hold the key, housing this missing matter in the form of diffuse gas that is incredibly challenging to detect. This discovery could help bridge the gap in our understanding of how galaxies and the universe as a whole evolve. Speaking of galaxies and their enigmatic features, let us delve into the phenomenon of ultra-diffuse galaxies. These galaxies are particularly intriguing because, despite having similar sizes to the Milky Way, they contain only a fraction of its stars. This sparse population makes them almost ghostly, as their low surface brightness makes them difficult to observe. Yet they possess a higher proportion of dark matter compared to their more luminous counterparts. Scientists believe that ultra-diffuse galaxies may hold clues about the impact of dark matter on galaxy formation, as well as the processes that strip galaxies of their stellar content. A curious fact about ultra-diffuse galaxies is their potential association with globular clusters, which are densely packed groups of stars orbiting the galaxy. Some ultra-diffuse galaxies host a surprisingly large number of these clusters, suggesting a turbulent past involving galactic collisions or interactions. This connection might reveal insights into the violent histories of galaxies and the cosmic events that shape them. The presence of numerous globular clusters could indicate that ultra-diffuse galaxies are survivors of ancient galactic mergers, with their stellar populations dispersed, but their globular clusters remaining intact. This paints a picture of resilience and transformation on a cosmic scale. The study of galaxies also introduces us to the captivating realm of molecular clouds, the birthplaces of stars. These dense regions of gas and dust within galaxies are where the magic of star formation begins. Molecular clouds can span light years in diameter and hold enough mass to form thousands of stars. Within these clouds, gravity comes into play, causing them to collapse and form dense cores that eventually ignite nuclear fusion, giving birth to new stars. The composition and density of these clouds vary, influencing the types of stars they produce and the overall dynamics of the galaxy they reside in. Interestingly, molecular clouds play a pivotal role in the chemical enrichment of galaxies. As stars form and evolve within these clouds, they generate heavier elements through nuclear fusion. When these stars eventually die, they scatter these elements into the interstellar medium, enriching the galaxy with new materials that will be incorporated into future generations of stars. The cycle of creation and destruction within molecular clouds is a fundamental aspect of galactic evolution, demonstrating the interconnected nature of the universe. This cosmic recycling process ensures that galaxies remain active and dynamic, constantly evolving in response to the star formation within them. One might wonder how we detect these elusive molecular clouds. Astronomers employ a variety of methods, often using radio telescopes to observe the specific wavelengths of light emitted by molecules like carbon monoxide. This enables them to map the distribution of molecular clouds within galaxies, even in regions obscured by dust. By understanding the properties and distribution of these clouds, scientists can gain insights into the star formation rates of galaxies, offering a window into their past, present, and future. Exploring further into the realm of galaxies, we encounter the intriguing concept of galactic fountains. These are large-scale outflows of gas from a galaxy's disk, propelled into the halo by energetic events such as supernova. Once in the halo, the gas cools and eventually falls back onto the galaxy, much like water in a fountain. This process helps regulate star formation by cycling gas in and out of the galaxy, maintaining a delicate balance. Galactic fountains contribute to the chemical mixing within a galaxy, ensuring that newly formed stars are enriched with a variety of elements. Galactic fountains are vital for understanding how galaxies maintain their gas supplies and continue forming stars over billions of years. Without these fountains, galaxies might deplete their gas reserves too quickly and cease star formation. They illustrate the dynamic nature of galaxies, where even seemingly chaotic processes contribute to stability and longevity. The interplay between galactic fountains and other phenomena, like molecular clouds, reveals the complex mechanisms that govern a galaxy's life cycle. Considering the grand scale and intricate details of galaxies, it's awe-inspiring to ponder the cosmic tapestry they weave. Each galaxy, with its unique combination of stars, gas, and dark matter, is a testament to the universe's creativity and complexity. Galaxies not only shape the universe but also tell the story of its evolution, from the earliest moments after the Big Bang to the distant future. On a personal note, contemplating galaxies invites us to reflect on our place within this vast cosmic narrative. The knowledge that we are made of the same elements as the stars and galaxies connects us to the universe in profound ways. This connection inspires a sense of wonder and curiosity, encouraging us to explore and learn more about the cosmos. As we gaze at the night sky, we can appreciate the beauty and mystery of the galaxies that dot the universe, knowing that they are part of our shared history. The exploration of galaxies, with all their mysteries and wonders, reminds us of the boundless potential for discovery that lies beyond our planet. Each revelation about galaxies deepens our understanding of the universe and our place within it, inspiring us to continue seeking answers to the questions that drive our curiosity. As we journey through the cosmos, let us cherish the insights and inspiration that galaxies provide, guiding us on a path of endless discovery and wonder. In the vast expanse of the universe, galaxies serve as the cosmic stage where stories of creation, transformation, and continuity. Each galaxy, with its distinctive characteristics and evolution, adds another thread to the intricate tapestry of the cosmos. Their diverse structures and dynamics offer endless avenues for exploration and discovery. As we delve further into these celestial wonders, let us consider the intriguing phenomena that make galaxies such captivating subjects of study. One aspect that often goes unnoticed is the role of hot gas halos surrounding galaxies. These halos, composed of exceedingly hot, ionized gas, extend far beyond the visible boundaries of galaxies. They are reservoirs of baryonic matter, potentially containing more material than the galaxies themselves. By examining these halos, astronomers can glean insights into how galaxies acquire and lose mass over time. The heat of these halos is maintained by energetic processes such as the accretion of material onto the galaxy, or the feedback from active galactic nuclei. These halos not only play a crucial part in regulating star formation by influencing the inflow and outflow of gas, but also contribute to a galaxy's long-term stability. Another fascinating feature is the presence of tidal dwarf galaxies, which are born out of the gravitational interactions between larger galaxies. When galaxies collide, the immense gravitational forces can draw out streams of gas and stars, forming new, smaller galaxies. These tidal dwarf galaxies provide a unique glimpse into galaxy formation, as they often contain a substantial amount of dark matter and exhibit unusual star formation properties compared to their parent galaxies. Their existence hints at the dynamic and interconnected nature of galaxies, constantly reshaping each other through cosmic encounters. The study of starburst regions within galaxies reveals another layer of complexity. These regions experience intense and rapid star formation, often triggered by external factors such as galaxy mergers or interactions with intergalactic matter. Starbursts can convert vast quantities of gas into stars in a relatively short period, dramatically altering a galaxy's appearance and dynamics. The energy emitted by these young, massive stars can also drive powerful winds, redistributing gas and affecting future star formation. Starburst regions serve as natural laboratories for understanding the processes that govern star formation on galactic scales. Galaxies, as we've seen, are not isolated entities, but integral parts of the larger cosmic web. Their interactions with one another and with the intergalactic medium shape their evolution in profound ways. The presence of cosmic filaments, vast structures composed of galaxies and dark matter, highlights the interconnectedness of the universe. These filaments act as highways for galaxy movement and material exchange, influencing galaxy formation and growth. The flow of matter along these filaments can feed galaxies, fueling further star formation and potentially triggering galactic mergers. In our exploration of galaxies, we also come across the intriguing concept of galactic canyons. These are regions within galaxies where the gravitational pull from nearby structures creates areas of lower density. Galactic canyons can affect the movement of stars and gas, leading to the formation of unique structures and patterns within the galaxy. By studying these canyons, researchers gain insights into the gravitational dynamics at play in galaxy clusters, further illustrating the complexity of galactic environments. Considering the cosmic dance of galaxies, let us not forget the cosmic voids, vast regions of space with relatively few galaxies. These voids can stretch across hundreds of millions of light years. Understanding the distribution and properties of these voids offers valuable information about the large-scale structure of the cosmos and the processes that govern galaxy formation and distribution. As we reflect on these myriad aspects of galaxies, it becomes clear that each galaxy is a complex, ever-evolving system. Their stories are written in the language of stars, gas, and dark matter, with each element contributing to the grand narrative of the universe, from the formation of the first galaxies to the intricate interactions that continue to shape them today. Galaxies remain a source of endless fascination and discovery. The more we learn about galaxies, the more we appreciate the delicate balance and intricate relationships that sustain the cosmos. Each galaxy, with its unique history and characteristics, adds to the richness and diversity of the universe. By studying galaxies, we not only uncover the secrets of the universe, but also gain a deeper understanding of our own place within it. In this vast and ever-changing cosmos, galaxies serve as a reminder of the beauty and complexity that surrounds us. Their stories inspire us to look up at the night sky with renewed wonder and curiosity, knowing that each twinkle of light represents a galaxy full of mysteries yet to be unraveled. As we continue our journey through the universe, let us remain open to the discoveries that await, cherishing the insights that galaxies offer us about the nature of existence and the interconnectedness of all things. Galaxies, those vast luminous assemblies scattered throughout the universe, serve as profound reminders of both the grandeur and intricacy of the cosmos. As we explore these cosmic entities, we discover that they are not solitary travelers but interwoven parts of a larger cosmic drama. Their stories are etched in the stars, echoed in their swirling arms, and whispered through the dark matter and energy that bind them. Now, let's delve deeper into the subtle wonders that make galaxies such endlessly fascinating topics of study. One of the lesser-known but captivating features of galaxies is the concept of galactic fountains. Just as terrestrial fountains propel water into the air, galactic fountains are processes by which hot gas is ejected from the galactic disk, only to rain back down in a cooling cycle. This cyclic nature of gas helps regulate star formation within a galaxy by cooling the material, allowing it to collapse under gravity and form new stars. It's a fascinating glimpse into how galaxies maintain their star-forming abilities over billions of years. Moving from the tangible to the complex, let's consider the mysterious magnetic fields of galaxies. Although they are invisible, these fields play a crucial role in galaxy dynamics. They are believed to be generated by the motion of ionized gas within galaxies, and they influence the movement of charged particles and cosmic rays. These fields can stretch across entire galaxies, shaping the paths of gas clouds and affecting star formation. Understanding them requires sophisticated technology and provides insights into the magnetic history of galaxies. Galaxies also offer a unique window into the past through their light. The light we observe from distant galaxies has traveled vast distances, taking millions or even billions of years to reach us. When we look at these galaxies, we're essentially peering into the past, seeing them as they were long ago. This natural time machine allows astronomers to study the evolution of galaxies over time, piecing together the cosmic history from the early universe to the present day. Another intriguing aspect is the phenomenon of galactic cannibalism. This term refers to the process where larger galaxies merge with or absorb smaller ones, a common event in the universe. This cosmic consumption leads to the growth and evolution of galaxies, contributing to their diversity and complexity. Through this process, galaxies evolve from smaller building blocks into the massive structures we observe today. It highlights the dynamic and often violent nature of the galactic environment. In terms of sheer scale, consider the superclusters, which are among the largest structures in the universe. These colossal formations consist of thousands of galaxies bound together by gravity, forming immense filaments and sheets that stretch across hundreds of millions of light years. These vast structures help us understand the large-scale distribution of matter in the universe and the gravitational forces that shape it. Looking at the individual components of galaxies, we find the globular clusters, dense collections of stars that orbit the galactic center. These clusters are some of the oldest objects in the universe, providing clues about the early stages of galaxy formation. Observing globular clusters allows astronomers to estimate the age of the galaxy and trace its evolutionary history. Let me share something particularly curious about galaxies: the presence of galactic fountains. These aren't physical fountains like those we might stroll by in a park. Rather, they are phenomena where gas is expelled from the galaxy only to cool and fall back into the central regions. This cyclical movement helps distribute elements throughout the galaxy, mixing the rich, star-forming materials and sustaining the life cycle of stellar creation. Moreover, did you know that galaxies sometimes produce jets of particles that stretch out for thousands of light years into space? These jets, often emanating from the active central regions of galaxies, are driven by the supermassive black holes at their cores. The energy within these jets can illuminate gas clouds far from the galactic center, providing a spectacular show and revealing the energetic processes occurring within. Speaking of supermassive black holes, another intriguing aspect is the concept of feedback loops. These loops involve the flow of energy and matter from the black hole, affecting the host galaxy's gas and star formation. The interaction between the black hole and its galaxy can regulate the growth of both, creating a delicate balance that shapes the evolution of galaxies over cosmic timescales. Galaxies also engage in a dance of proximity, often forming groups or clusters bound by gravity. The Milky Way, for instance, is part of the Local Group, a collection of over 50 galaxies, including the Andromeda Galaxy. These groups can merge over billions of years, leading to the formation of larger galaxies and providing an insight into the merging process that has shaped much of the observable universe. As we examine the peculiarities of galaxies, consider the phenomenon of galactic mirages. These optical illusions occur when the light from a distant galaxy is bent around a massive object, such as a galaxy cluster, due to gravitational lensing. This bending of light can create multiple images of a single galaxy or even stretch it into arcs. Such phenomena offer a window into the distribution of dark matter, as the lensing effect is primarily influenced by its presence. Lastly, let us reflect on the potential for galaxies to host life. While stars and planets are the most immediate hosts of life, galaxies create the conditions necessary for planetary systems to form and evolve. By distributing essential elements and sustaining the right environmental conditions, galaxies set the stage for the emergence of life as we know it, raising profound questions about the existence of life beyond our own planet. The exploration of galaxies provides endless opportunities for discovery and awe. Each galaxy, with its complex interplay of stars, gas, and dark matter, tells a unique story. Their sheer diversity reflects the boundless creativity of the universe, inviting us to contemplate our place within this vast cosmic tapestry. As our understanding of galaxies deepens, so too does our appreciation for the intricate wonders of the cosmos, nurturing our curiosity and inspiring us to continue our journey of exploration and understanding. As we drift gently through the cosmos, the galaxies we've journeyed through remind us of the incredible vastness and intricate beauty of the universe. Each galaxy, from the smallest dwarf to the grandest spiral, holds countless secrets waiting to be uncovered. Our exploration highlights the delicate balance of forces that govern these celestial structures. With each discovery, we unravel more of the universe's history, piecing together a tapestry woven from stardust and gravity. Galaxies themselves, beyond their visual splendor, play a crucial role in shaping the universe. Their gravitational pull helps to organize matter into vast cosmic structures, creating the framework for the universe we see today. This cosmic architecture, though mind-boggling in scale, is grounded in the fundamental laws of physics, which guide the dance of galaxies across space and time. It's a humbling reminder of the unity of all things within the universe. Have you ever considered the starry sky as a living record of the universe's past? Each twinkling star and glowing galaxy is a time capsule, carrying light that left its source eons ago. By observing these distant luminaries, we're not just seeing points of light, but glimpsing the universe's own history, written in the language of light. This ongoing narrative enriches our understanding of cosmic cycles, from the birth of stars to the majestic sweeping arcs of galactic evolution. Among the fascinating aspects of galaxy formation is the role of supermassive black holes at their centers. These enigmatic entities, often millions of times the mass of our Sun, exert a profound influence on their host galaxies. Their gravitational pull governs the movement of stars and gas, while the jets and radiation they emit can trigger or suppress star formation. They are both creators and destroyers, highlighting the duality of nature on the grandest scales. In our quest to understand galaxies, technology serves as our lens, allowing us to peer deeper into space. Upcoming missions promise to reveal even more about galaxy formation and evolution. Telescopes equipped with cutting-edge technology will probe the early universe, searching for the very first galaxies that emerged from cosmic darkness. These missions, fueled by international collaboration, remind us of the shared human endeavor to comprehend our place in the cosmos. Consider for a moment the vast networks of galaxies spanning the universe, connected by the invisible threads of dark matter. This cosmic web not only shapes the universe, but also offers a glimpse into the unseen forces that govern it. By mapping these structures, astronomers are uncovering the underlying patterns of the universe, providing a framework for understanding everything from the smallest particles to the grandest cosmic scales. Yet, as we uncover the mysteries of galaxies, we must also ponder the future. The universe is not static, it is constantly changing. The galaxies we see today will continue to evolve, merging and transforming as they have for billions of years. This cosmic dance of creation and destruction will forge new stars, planets, and possibly life itself. The study of galaxies offers a glimpse into the cycles that define the universe, cycles that mirror the ebb and flow of life on Earth. Our journey through the galaxy highlights not just the wonders of the universe, but also the beauty of discovery. Each new fact we uncover deepens our appreciation for the complexity and elegance of the cosmos. It is a reminder that the universe is a vast, interconnected entity where every galaxy and star plays a part in a larger story. These insights inspire us to continue exploring, to push the boundaries of our knowledge and imagination. As you reflect on the galaxies we've explored, take a moment to gaze at the night sky yourself. Let the stars remind you of your connection to the universe, a connection that stretches across time and space. The same atoms that make up the stars also form the building blocks of life on Earth, linking us to the cosmos in the most profound way. This connection fosters a sense of wonder and curiosity, encouraging us to seek out the unknown and cherish the mysteries that remain. In closing, I invite you to continue this journey of discovery, to explore the universe's secrets with an open heart and mind. As we unravel the mysteries of galaxies, we find not just answers, but deeper questions that drive us to learn and grow. Together we can uncover the wonders of the cosmos piece by piece and marvel at the beauty and complexity of the universe we call home. Rest well, knowing that the night sky is always there to guide and inspire. Sweet dreams. and good night.